when you have an equation, when you have every term inside logarithm, what you want to do is you want to condense these logarithms into a single one on each side. So again, the goal is to end up with one logarithm on the left and one logarithm on the right. And if they have the same base, which we do here, then you find the answer by setting the inside of these equal to one another. All right, so I know that may not make a whole lot of sense, so let me go ahead and do example 1. So on this one, again, my goal is I already have one logarithm here. On the right side, I want to condense this into a single logarithm. So if you remember those properties that we went over on Tuesday, the first thing I have to do is bring that 2 up as a power. So I have log base 2 of x is equal to log base 2 of 3 squared plus log base 2 of 5, right? And again, you can probably do this faster if you understand it. Now, remember that this is, if I simplify this would be log base 2 of 9 plus log base 2 of 5. Now, I want to condense this. I want to condense this into a single logarithm. And to do that, remember, if I have a plus, I can actually multiply that 9 and that 5. All right, so on the left side, I still just have log base 2 of x. But on the right side, I'm going to have log base 2 of 45. Because that's what 9 times 5 is. Okay? Now, when I get to that point, when I have one logarithm on the left and one logarithm on the right, then the next step is to set the insides, like that, equal to that. And sometimes, like in this case, you don't even need to solve. That's the answer right there. So that's it for that one. Okay? So again, remember, you're trying to condense each logarithm on each side. On example number 2, same idea. On this one, remember, you cannot have a number in front of the logarithm. You want to condense this. So I'm going to bring this up as a power. So this is going to be log base 2 of x cubed is equal to log base 2 of 8. And then once there, then I'm going to set the inside of each logarithm equal to one another. All right, so I have x cubed is equal to 8. And then I solve for that. So on this one, I do have to solve. So in order to get rid of that cube, I'm going to take the cube root of each side. So I'm going to write the cube root of each side. So this is going to be x is equal to 2. So that's it for that one. All right, so again, you got to be familiar with those rules that we have used, that we used on Tuesday, and we've kind of partly used on Wednesday. All right, now on number 3. Number 3, you can take one step at a time here, but if I have a log base 7 of x plus a log base 7 of x, I can actually multiply those two things together. All right, so this is going to be log base 7 of x squared minus log base 7 of 3 is equal to log base 7 of 12. And then after that, I am going to condense these two. Right, and to condense those two, I have a minus here, which means I can divide. So I have log base 7 of x squared over 3 is equal to log base 7 of 12. Right, and once you get there, so once you got to that point where you have one logarithm here on one side of the equal sign and another logarithm on the other side of the equal sign, then you're just going to set that equal to that. So we have x squared over 3 is equal to 12. All right, now this one you have a choice about how do you want to proceed. You can either multiply both sides times 3, or what I like normally to do is I like to set this number over 1 and cross multiply. So this is going to be x squared is equal to 12 times 3, which is 36. And then finally you take the square root. Haley Harden, is there a reason you're on your phone? All right. Come on now. I see you all kids. Right, so on this one, it's only going to be positive. Remember, this is, and there's a reason I'm telling you this. Right, I cannot have a negative answer, I can only have a positive logarithm. So what I mean is, if I plug this negative value into here, I get a negative logarithm, which is, I can't have that, it's undefined, it's not in the domain. Alright, so, anyway, so yes, only positive. Now on the back, go ahead and try to condense this, at the very least, try to show me how to condense this and set that equal to that. So try to see if you can do this on your own in the next, like, 30 seconds. Right. So again, try to condense that. Right, if I have a minus, how can I combine those two? You guys are sort of good, yeah. When you subtract the dot, so it's going to be log base 8 of 48 divided by x. Again, if you're subtracting, if you subtract, you can divide. So you can condense these two logarithms into one by dividing 48x. Okay. So assuming that some of you did that right, I'm sure some of you still need more help, but if you combine those two logarithms, I would have log base 8 of 48 over x is equal to log base 8 of 4. And then at that point, I'm just going to set the inside equal to one another. So I have 48 over x is equal to 4. And then now I need to solve for x. Any idea how to solve for x in this?
4x.
Yeah. Yeah, we can cross multiply, so I get 4x is equal to 48. Yes. And then if I divide both sides by 4, I get 12. So x is equal to 12. All right. Okay, now on number 5, if you look at number 5, there's really nothing to do because you only have one logarithm on each side. All right, so if I have a logarithm here and another one here, you're going to set it equal to one another. There's not a whole lot of work to do other than to do this. This is already simplified. And then you just solve for that, right? So I'm going to solve for this pretty fast. No. Let's see. Subtract 3x. Add 12. So I get 17 is equal to 5x. Divided by 5. So x is equal to 17 over 5. Okay. Any questions so far? All right, so let's go to the last one, which is the hardest. You have maybe one like this in the homework. But again, the logic is the same. I need to condense, or I need to combine this logarithm into one, and I need to combine this logarithm into one. So before I do that, I'm going to bring this up as a power. I'm going to bring this up as a power. And remember, if I'm subtracting, I can divide. So this is going to be log base 2 of 2x minus 1 over x plus 5 is equal to log base 2 of 36 to the 1/2 power. Well, I'm going to write this in 2 steps. Log base 2 of 2 squared. That looks really weird, but anyway. This left side is not going to change. Although, you know what 36 to the 1/2 power is? What's the square root of 36? That's the same thing. Okay, so this is going to be log base 2 of 6 over 2 squared is 4. So I have that. Now I have one logarithm on each side. I'm going to set the insides equal to one another. 6 over 4 is 3 over 2. How do you solve for x on that? Kind of the same way we did like 3 and 4. If you have two fractions, you can cross multiply and then solve for x afterwards. Alright, so I'm going to cross multiply. So I'm going to multiply 2 times 2x minus 1, and I'm going to set that equal to 3x plus 5. Like that. And then now I'm going to multiply here, distribute. Alright, and then I'm going to solve for x. So x is equal to 17. Alright, so hopefully that's not too bad. I feel like it's not terrible, but it's helping you to remember those rules of condensing and expanding. Now, I'm going to go ahead and go to the homework and show you the answers to the homework just to make sure, give you some reassurance if you're doing this right or wrong. Alright, so here are the answers for the homework. First 4. So the last 4. What's that? Number 2 was 5 over 2. Or 2.5, either one. Okay, do we all have those answers from the front page?
Sir.
Alright, let's go to the back. Here is the back. Those are the first two. And I'm not sure who's that. Alright. So, brief lesson for the people that were not here. So I'm going to show you the last two, but I'm going to do number 13. So number 13, it's like the ones you guys were doing yesterday, right? So for example, Haley and Lauren, this is what we did yesterday, right? It's not any harder than what we did today. So in this one, notice that not every term is a logarithmic term, right? I have a number here, so it's not quite the same. But what I need to do is I need to isolate this logarithm right here. I need to get that by itself. So to do that, I'm going to start off by adding 6. So this is going to be 6 log base 10 of x is equal to 30. So again, notice that I'm trying to isolate the logarithm. Right? And after I do that, then I'm going to divide by 6 again, because I want to get the logarithm by itself. So I'm going to divide this by 6. I'm going to divide this by 6. So this is log base 10 of x is equal to 5. Right, so at that point you're kind of stuck. You can't really set the x is equal to 5. It doesn't work like that. Notice that on this one I have one logarithm and one number, so it's different than what we did today. Excuse me. So what we're going to do is we're going to turn this into an exponential function like we did yesterday. That's the base of my exponent. So this is going to be 10. Right, and I'm going to switch this x and this 5. So this 5 is going to become the power of 10. And that's just going to be x. So that's the answer for number 13. Okay. So, and then the next one, the one that I'm going to let you do it on your own. It's x is equal to 49. All right. So for you two that were not here, I'll share a video. She can share it with you. I sent it to her, and then I'll share it with you. So if you have any questions, refer to that first. Now, before I forget, let me turn off.